You'll make your life a lot easier if you look for the greatest common factors before you start anything that's more complicated. So in the first, we have a 4 that's in common with the two terms. Here's a term, and there's a term. It starts with a positive or negative sign between the terms. That's how you know when another one begins. In this case, we have 4's that we could take out of this particular one, and it would be, the 4 would come out, and we would have an A minus B. If we multiplied that back, we should get this term here. This would be a 4A, and if we did this part, we would have negative 4B. Do you see how that came back? So this would be your answer for a greatest common factor, right here. Noticing what's common in this one, we've got a 1/3 in both of them. We have an x term in both. Then we have a y and a z. So those are different. So we're going to be able to take out 1/3 x. And then the y and the z have to go separately. And if we FOILed this back, it would be 1/3 xy. And multiply this part, we would have plus 1/3 xz. And we're back to where we started. This would be your factors. In this case, our a's are the same in both of the terms. So an a could come out, and then we would have b minus c. That's your answer. That's your factor. And if you distributed, you would get AB minus AC. That's how easy it is to do your greatest common factor. And it greatly simplifies the actual polynomial. Here's another example of taking out the greatest common factor. We're going to need to find our terms. One term begins with a positive or negative sign. So we've got 4 terms in this polynomial. Now we can list the terms of the polynomial. We have a 4, 2 a's and a b. This one is a negative 10, an a and a b. Here we have a negative 6, a b and a c and a c, and 2, positive 2, b. Now we can see what they have in common. First of all, we'll look at our numbers. This has to do with divisibility. It's a great opportunity to use your divisibility rules. I have 4, negative 10, negative 6, and 2. They are all even numbers. That's the first question I always ask myself. Are they even? Yes. Oh, good. I can take a 2 out of it. That's the highest I can go because this one is only a 2. So to be able to take something out of this term, it would have to be 2. So let me pull the 2 out. When I do that, I'm going to actually adjust the other numbers. So 2 taken out of a 4, 4 divided by 2 is 2. Negative 10 divided by 2 is a negative 5. Negative 6 divided by 2 is a negative 3. And 2 divided by 2 is 1. In my a terms, I don't have a's right across. Every term doesn't have an a in it, so the a's have to stick right now. The b's, however, there's a b in each of the terms, so a b can come outside of this. And we only have c's in this one position. We're done with removing what we can for the greatest common factor. I'm going to go back and circle what I haven't used so it's obvious to me. So that's our first parenthesis. Our second parenthesis is a listing of everything that's left. So in this particular term, I have a 2a squared left minus 5a minus 3c squared. And this term got completely wiped out, but I need to represent it with a 1 in order to have the distribution back work. Now, I'm pretty sure that this is my answer, but I'm going to check it just to ease my mind. All right, in the first position, I've got a 4a squared b minus a positive times a negative is a negative. So now we're going to go to negative 10ab. Next, positive times a negative is a negative. 2 times 3 is 6b c squared. And the last term is a positive times a positive. And anything times 1 is that number, so we have 2b. Let's see if it matches. 4a squared b minus 10ab minus 6b c squared plus 2b. And that's how you pull out the greatest common factor from a long polynomial.